Good morning to all of you. Today we are going to discuss a new topic, that is your special theory of relativity. Why this theory came? Because with the help of Michaelson-Morley experiment, we could not identify the presence of ether medium which can justify the Galilean transformation. So at the time of Galilean transformation or limitation of Galilean transformation, we found that u dash will be c minus b. In short, I am discussing, okay. U dash may be u c plus b. That means any velocity will be either less than that of the light velocity or greater than that of the light velocity. It can be possible, these two equation can be possible if we have a ether medium surrounding us. But Michelson-Morley experiment, or with the help of experiment, whenever we are trying to find out the presence of ether medium, we failed to detect that ether medium is to be present. So Michelson-Morley experiment we have been discussed in detail, that at last we found that fringe shift should have to be a significant value, but fringe shift we not found. Only for that we have been concluded that there is no presence of ether medium to justify that a frame of reference or a speed of a another particle or body may be less than or may be greater than that of the speed of the light. So hence, to overcome this problem, Einstein around 1905 has been published or given this theory. Okay, so in detail we are going to be discuss this theory. Yes, this theory based upon two postulates or two laws, we can say. One is principle of relativity and another is principle of consistency of the speed of the light. These two principle or two postulates Einstein given. Then after he taken the theoretical derivation of Lorentz and explain the special theory of relativity, that we are going to be discussed today in detail. Okay, so I suggest to you, whatever I'm saying to you, that you have to write down your note. You just write, because those things may be theoretical, but you have to be write in your note. See, the theory governing the space-time relationship is called special theory of relativity. Around 1905, Albert Einstein published a research paper which was based upon theory of relativity. Subsequently, theory grew due to contribution from Einstein, Poincare, Lorentz, and Minkowski. The theory is based on two simple postulates. The first postulate is principle of relativity. The laws of physics are same in all inertial reference frame. No frame is singled out as P referred. So again I am studying this one. The laws of physics are same in all inertial frame of reference and no frame is singled out as preferred. That means whatever the reference we have to take, in that reference the laws of physics will be the same. That means Newtonian mechanics or Newtonian dynamics will be the same in all frame of reference wherever you have to take. That is the first postulate. Second postulate is that the speed of the light in the free space has the same value in all inertial frame of reference or in all inertial reference frames. This is the important point, whatever has been modified as compared with Galilean transformation, and whatever the conclusion we have been found from Michelson-Morley experiment, that the speed of any particle may be greater than or less than that of the speed of the light, but according to this postulate, the speed of the light is always same, whatever may be the frame of reference. That frame of reference is moving with another frame of reference or in steady state with another frame of reference, whatever may be the situation. In all frame of reference, the light speed always the same. Okay, these are the two basic postulates, or we can say law of special theory of relativity. So I suggest to all of you that you have to just write in a note this much and two postulates, and to pause the video and write down the note, two postulates. And this theoretical part may you can study whatever we have been discussed uh, just previously, that how Galilean transformation is not going to be valid when the speed is concerned with light speed, like that. Now, the special theory of relativity has been derived or is going to be explained with the help of Lorenz transformation. See, this is the Lorenz transformation. That means Lorenz is one, we can say, mathematician. Hendrik A. Lorentz, 1853 to 1928. He is the one of the mathematician. He derived the mathematics uh, on the base of these transformations equations, and at that time Einstein has been saw that those mathematical relations will be or can be helpful to explain the theoretical special theory of relativity. So Lorentz transformation is or Lorentz equations, whatever we are going to be discuss now, this is the main part of the special theory of relativity, uh, that what we are going to be discuss. So coordinate transformation equation that agree with two basic postulates of special theory of relativity were first derived by Hendrik A. Lorentz. They are called Lorentz transformation equation. These equations relate the position and time measurement of an event by one observer to corresponding measurements by another observer in motion relative to first. So what is that transformation? See, suppose these are the two frame of reference, one is S and one is S dash. Initially both are coincided with each other, and let's consider S dash is moving towards right or along x dash coordinate with the velocity v. Then what will be the scenario, or what will be the equation that we are going to write? Same thing it has been written, and I suggest that you just change the figure number. Here it is written that figure 14.6, so you have to write figure 1. Okay, figure 1 shows two inertial frame of references, S and S dash. The x, y, z coordinates are attached to the S frame, and x dash, y dash, z dash coordinate axes are attached to S dash frame. The x, y, z and x dash, y dash, z dash axes are mutually parallel with x and x dash axis coincident, or initially it is parallel coincident. Axes are coincident or parallel, you can say. An observer with a clock at rest at origin O, that means in S frame of the S frame it is written. Another observer with a clock is rest at origin O dash of the frame S dash. Okay, so we assume that I have to just somewhat zoom. We assume that the origins of S frame and S dash frame are coincident or simultaneously exist, or you can say coincided when the clock S and S dash read 0. Suppose one person is in this S frame, another person in S dash frame. Initially when both two frames at O, the time records by this observer and this observer is to be 0. Okay, now what will be happen if one frame of reference is going to move with a velocity v? See, the S frame is stationary, this S frame is stationary. The x dash axis of S dash frame, here you have to change, here just somewhat mistake is that the x dash axis of the S dash frame moves to the right with velocity v relative to x axis. Relative to x axis, here is the full stop. Then sentence starts from here. An event observed in S system will occur at position whose coordinates x, y, z at time t, and the same event observed in S dash frame, S dash system or S dash frame you can write, will have coordinates x dash, y dash, z dash and t dash. Obviously both are two different frame of references. For S dash we considered x, y, z, t. For S system we considered x, y, z, t. For S dash it is x dash, y dash, z dash and t dash. And we know that the Galilean transformation equation for x motion are x dash equal to x minus vt, or we can say x equal to x dash plus v t dash. These two equations previously we have been derived. In this equation, yes, here I am going to suggest that you just write this is equation number 1, this is equation number 2. No need to write this is written here, it is written 14.23, 14.24, but you have to write in your note that is equation number 1 and 2. Okay. So in equation number 14.24 means equation number 2, t dash takes into account the possibilities of different time scales. Since the length scale may change, this is the most important two words, may change, we introduce a scale factor gamma. So here, as Galilean transformation could not provide the perfect answer when the speed of light is going to be concerned, so only for that, this x dash or change of x coordinate in s dash frame can be changed with the factor gamma. Gamma x minus vt or x equal to gamma x dash plus vt dash. This symbol is nothing but gamma. This symbol is called as the gamma. Okay. So you just write this is equation number 3 and this is equation number 4. Again I am going to be explain. See, t dash can be considered as different time scales. So t will be t dash may be in so that may be vary. This t dash may be vary with different time scales, and the length scale whatever not to be justified with the help of Galilean transformation, it has been changed to gamma into x minus vt, or the so called x will be equal to gamma into x dash plus vt dash. Let it is equation number 3 and it is your 4. And as this frame of reference s dash is moving only along x axis, so obviously y dash is not going to be changed, z dash is not going to be changed. So in the Galilean transformation this is not to be changed, y dash will be y, z dash will be y, z dash will be z. So here also in case of Lorentz transformation, y dash will be y and z dash will be z. And this is your equation number 5 and this is your equation number 6. So just before we discussed that these transformations will be helped to identify the coordinate transformation, or to determine x dash, y dash, z dash and t dash when the system or when the frame of reference or when the particle is moving with the velocity which is approximately speed of the light. Approximately speed of the light. So as with the Galilean transformation, the prime and non-prime coordinates should be the same for axis perpendicular direction of motion of the frame. They correspond to the homogeneity isotropic space. So y dash equal to y, equation number 5, z dash equal to z, equation number 6. Gamma has the same value in case of equation number 3 and equation number 4. The only restriction of gamma is that it must approaches unit as v by c approaches to 0. So gamma we have to consider in such a way that when v tends to c, the gamma value will be approaches to 0. The sentence is this one. That means gamma value will be 0. Gamma value will be 0 when v approaches to c. This is because Galilean relativity holds for the velocities that are the same compared to the velocity of light. So in this way, the Galilean relativity can be considered as comparatively same with the Lorentz transformation if we have to consider this gamma factor. Okay, that means if we are going to be multiply gamma factor with the Galilean transformation, it will be another new transformation which will be the so-called Lorentz transformation. So now we have to evaluate the gamma. What will be the value of the gamma? Okay. So put a heading that evaluation of gamma and draw this figure. Suppose that the origins of S frame and S dash frame are coincide when clocks in S and S dash read 0. That means this S dash frame and S is coincided with each other at t equal to 0. And there is a flash of light from a source at coincident origins. Here origin is O and O dash. When t equal to 0, both the origins are coincided at here. So at that time, a flash of light is going to be on in S frame. Okay, the light moves out along the x-axis with the speed of the c measured by the observer in S. So when a light is going to be flash, the light speed will be c, that will be observed a portion which is in the frame of reference S. The light also moves out along x dash with the speed c as measured by observer in S dash according to the second postulate. So here the person who is standing in this S dash frame, and with that S dash frame moving with a velocity, some velocity v, that observer also measure the speed of the light also c. Okay, but in case of Galilean transformation, it was c minus v. Okay, but here that this observer who is in the S dash frame also observe the speed of the light is c. According to second postulates, that is your in all frame of reference, the speed of the light is same. So hence x will be equal to ct and x dash will be ct dash. Substituting, let this is equation number your this is your 6, this is your 7, and this is your 8. Substituting equation number 8, substituting equation number 14.29 means 14.29 means both these equation. So substituting equation, you have to write 7 and 8 into equation number 3 and 4. 3 and 4, what we are going to get here? We are going to substitute, instead of x dash it will be ct dash, instead of x it will be ct. Then we can found ct dash equal to gamma c minus v t, and ct will be equal to gamma c plus v t dash. Let it is your equation number 9 and this is your equation number 10. Okay, now we have to multiply these two equations 9 and 10. What we are going to get? Left hand side c square t into t dash, c square t dash is equal to gamma square c square minus v square t dash. This is in the form of a minus b, a plus b. So c square minus v square t into t dash. So c square will be equal to this t dash got cancel. So c square will be equal to gamma square into c square minus v square. Then further solve, if we are going to do, it will be gamma square will be equal to c square by c square minus v square. So dividing c square with each term, we can found 1 by 1 minus v square by c square. So here gamma can be plus or minus 1 by 1 minus v square c square to the power 1 by 2 or root over, you can say. Many books have been written as gamma equal to 1 minus 1 by v square by c square root over. So here it is written in the form of 1 by 2. So don't be confused. Gamma equal to plus or minus 1 by 1 minus v square c square b square by c square to the power 1 by 2. So here both the values is going to be accept or not, that is the question mark. Here plus or minus, what we are going to accept. A choice of minus sign leads to gamma equal to minus 1 sometimes. If when v equal to c, the gamma will be minus 1 at the coincident origin, x equal to 0, t equal to 0, x dash equal to, so in this origin, and subsequently x equal to x dash, which is not possible. So if we are going to be take gamma equal to minus 1, we can found x equal to x dash, which could not be accepted. So hence we have to reject the minus and we have to choose plus sign. So gamma value will be equal to 1 by 1 minus plus 1 by 1 minus b square by c square to the power 1 by 2. Late, it is equation number your 11. Last equation is 10. Yes, this is your equation number 11. Okay, now substitute equation number this 11 into equation number 1425. 1425 means this one, x dash gamma x minus vt. Now we have to substitute equation number 11 in equation number 3. So here substituting equation number 11 in equation number 3, what we are going to get here, equation number 3 is x dash equal to gamma x minus vt. So x dash will be here gamma value we are going to be put. That means x minus vt divided by 1 minus v square by c square to the power 1 by 2. So x dash in case of Galilean transformation, what we found, x dash equal to x minus vt. But in case of Lorentz transformation, whenever we are going to be derived here in this way, by considering the two postulates, Einstein's postulates, we found x dash is nothing but x minus vt by 1 minus v square by c square to the power 1 by 2. X dash value we found. Then we have to find out expression for t dash and t, because we here we defined that t dash will be different in different time scale and x dash may be changed, because as this frame of reference s dash is moving along x-axis, so x dash can be changed and y dash could not be changed, z dash could not be changed. So obviously time will be changed and x dash will be changed. So x dash, how much it will be changed, we at that time we could not identify. So only for that we written a gamma factor. So here we derived that gamma will be 1 minus v square by c square to the power 1 by 2. So x dash will be this much. So as y dash and z dash is not going to be changed, we are not going to be changed. So here we have to concentrate over t dash and t. That means what will be the changes with respect to t dash, or how t dash and t is going to be relate with each other. Because in case of Galilean transformation, it was a t dash equal to t, but in case of Lorentz transformation, it will be not so. How much it will be different, in which way both are different, that we are going to discuss now. Okay, so this is take equation number 12. You have to write this is your equation number 12. Now we have to find out relation between t dash and t, or you can put the heading expressions for t dash and t. So from equation number previously, that is we found that is your x dash equal to c t dash. From equation number 8 we found x dash equal to c t dash. So t dash will be equal to x dash by c. Okay, so from equation number 8 you have to write, from equation number 8 we found that is t dash equal to x dash by c, x dash by c. Now substituting equation number 12, this is equation number 12. Now substituting equation number 12 into equation number 8. equation number, this equation number you have to put a 13, equation number 13. Okay, now substituting equation number 12, this x dash value, now we are going to substitute in this equation. This is your equation number how much? 13. So we have to substitute x dash value in this equation. How much we can get? It will be t dash will be x dash by c. See, here x dash is this much, x minus vt by 1 minus v square by c square to the power 1 by 2. So x dash by c, x dash by c, x dash by c can be written as x by c minus vt by c by 1 minus v square by c square to the power 1 by 2. Okay, so same thing it has been written that x dash by c is nothing but, here x dash value is x minus vt by 1 minus v square c square to the power 1 by 2. So by whole divided by c can be written as x by c minus vt by c by 1 minus v square by c square to the power 1 by 2. Okay. See, again I am explaining that t dash is nothing but x dash by c, right? X dash we found how much? That is x dash we found x minus vt by 1 minus v square by c square to the power 1 by 2 whole divided by c. Okay, this can be written as t dash will be equal to x minus vt divided by c into 1 minus v square by c square to the power 1 by 2, right? And t dash can be written as x by c minus vt by c whole divided by 1 minus v square by c square to the power 1 by 2. Okay, same thing. This is this expression directly here it has been written, x by c minus v by c into t by 1 minus v square by c square to the power 1 by 2. Okay, x by c value we found how much? Equal to t from equation number 7. So here x by c value can be written as t. Here you just write from equation number 7. From equation number 7. Again, this t can be substituted as x by c. See, just I changed the writing format to find out a proper expression. I just written the, for simplification I written the format, writing format. X by c is substituted as t. Here t is substituted as x by c, which is from equation number 7 whole divided by 1 minus v square by c square to the power 1 by 2. Okay, so that implies t dash will be equal to t minus vx by c square whole divided by 1 minus v square by c square to the power 1 by 2. We know that 1 by 1 minus v square by c square to the power 1 by 2 is gamma. So here 1 by this much value can be written as gamma into t minus vx by c square. Let it is your equation number 14. Okay, so t dash value we found gamma into t minus vx by x square, and previously we know that this is not going to be changed. Y dash will be equal to y, z dash will be equal to z. So with conclusion or with summarizing the facts whatever we have been discussed, here we can write that x dash in case of Lorentz transformation with the help of special theory of relativity, we can write x dash how much we found, x minus vt by 1 minus a square b square by c square to the power 1 by 2 from equation number 12. Systematically I have written all the transformations. X dash will be equal to x minus vt by 1 minus v square by c square to the power 1 by 2. Y dash will be equal to y, is not going to be changed. Z dash will be equal to z, and t dash here we found how much, t minus vx by c square by 1 minus v square by c square to the power 1 by 2 is this much, or it can be written as gamma t minus vx by c square. So here x dash, here x minus vt by 1 minus v square by c square, or 1 minus v square by c square can be written as gamma x minus vt, y dash equal to y, z dash equal to z, and t dash will be equal to gamma 1 minus vx by c square. So these are the Lorentz transformations with the help of special theory of relativity. You have to remember these things. This will be required to do the problems whatever we are going to discuss in our coming classes. So this is equation number 14, and these equations can be, you can put a number 15 and 16. So in this format you have to remember gamma x minus vt, that is x dash, y dash equal to y, z dash equal to z, t dash equal to gamma t minus vx by c square. So these equations were first derived Lorentz, hence named after him. These are also Lorentz-Einstein transformation equation, because whenever Einstein accepted that no, c, the speed of light will be always constant with all frame of reference, at that time these equations or these transformations are helpful for him, for Einstein, to represent his theory, that is special theory of relativity. So they, as they are consequences, or you can say that correlated with Einstein's special theory of relativity. So basically theory of relativity, Einstein's special theory of relativity, based upon only two postulates. That is, all the Newtonian mechanics are holds good, are same in all frame of reference. That is your first principle or first postulate. Second postulate, that Einstein told that in all frame of reference speed of light is same. So with the help of these two postulates, Einstein correlated the transformations, mathematical equations of Lorentz, whatever at that time he has been derived, and he given that theory. With the help of that we can calculate the speed relative to another object, speed of one object relative to another object, when that speed is approximately velocity of light. Okay, so if we are going to consider inverse Lorentz transformation equation, just we have to, how it has been written, you just see x dash equal to gamma x minus vt, so x will be gamma x dash plus vt dash. Okay, you can put this is your equation number 17, and y dash is not going to be changed, so y equal to y dash, z equal to z dash. So this is inverse Lorentz transformation equation, means what, s dash is moving, s is steady. So we are going to find out all the coordinates from s dash. So it will be x dash, y dash, z dash, and t dash. But if we are going to just think about just reverse, that if this frame of reference, this s dash is moving with the velocity c with respect to s, similarly s is moving towards back with respect to s. If s dash will be steady, that we are going to be consider s is moving towards back with respect to s dash. If we are going to do so, then we can find out the so-called inverse equations or inverse Lorentz transformation equations. Only for that it will be x, that means x coordinate measured by the observer who is in s frame. So x will be gamma x dash plus vt dash, y could not be changed, y will be equal to y dash, z will be z dash, and if you are going to consider this equation, that means x dash gamma x minus vt, to find out the value of t, x dash equal to gamma x minus vt, so it will be equal to gamma x equal to x dash plus gamma vt. So now substituting this equation from equation number, you just write 16. Okay, now substituting this equation in equation number into equation number your equation number 14, that equation number 14 is how much, t dash equal to gamma t minus vx by c square. Okay, that means t dash will be equal to gamma t minus vx by c square into gamma See, equation number 14 is how much it will be gamma into t minus v gamma x by c square. Instead of gamma x, we have to substitute this value. So v by c square will be there, and instead of gamma x we have to substitute x dash plus gamma vt. Now we have to do the simplification. Take b square by c square x dash to the left side. It will be t dash plus v by c square x dash is equal to gamma into 1 minus v square by c square into t, or we can write 1 minus v square by c square to the power 1 by 2 into t, because this gamma is nothing but 1 by 1 minus v square by c square to the power 1 by 2. So here 1 minus v square by c square is there. So it will be 1 minus v square by c square to the power 1 by 2. See here, this is the gamma value is 1 minus v square by c square to the power 1 by 2. Here 1 minus v square by c square is at the numerator. So 1 half is going to be cancelled, means 1 minus v square by c square to the power 1 by 2 will be remaining into t. So t will be equal to t dash plus v by c square x dash by 1 minus v square by c square to the power 1 by 2, or gamma into t dash plus v by c square into x dash. This is your equation number 18. Okay, so in this way we found x equal to this much, equation number 17, and y equal to y dash, z equal to z dash, t will be equal to gamma t dash plus v by c square x dash. But here t dash equal to gamma t minus vx by c square. So these are the wait, this is equation number 19. You just write 19y, because this two equation you just write 18. Okay, 17, 18, 19. So 17, 18, 19 represents inverse Lorentz transformation equations. So with summarizing, the same three results has been written. So you can write with summarizing these three results once again. No need to write. So you just write after this equation number 9, you just write equation number 17, 18, 19 represents the inverse Lorentz transformation equations. So this is all about your special theory of relativity, Einstein's special theory of relativity, with the help of Lorentz transformation equation. So thank you so much for watching this video. Thank you.